Good day, guys. Happy New Year once more again. We had a technical glitch initially when we started at 7, but I feel like now we are now ready to go and we can start and proceed with the whole session. So, as I was saying earlier before that, the introduction to function was introduced to us from grade 10. Grade 8 actually, when we only taught about the straight line function, y is equal to ax plus b, or otherwise they will say like mx plus c. Then grade 10, 11, we're introduced to hyperbolic functions. We're also introduced to parabolic function and exponential functions. Then we delve more into them when we're in grade 11. But now in grade 12, we want to look at the inverse functions. We want to look at what is a 1 is to 1 function, what is a 1 is to many relation when it comes to function, what is a 1 to many, or what is this a function or not, when we use our vertical test line and horizontal, all the things which we are not doing in grade 12 is quite important. So we have this investigation. This is for Eastern Cape, if I'm not mistaken. This is due, I think, approximately next week. So now let's try to do memo. It was due last week, if I'm not mistaken, but let's try to do the memo for it. So what is important is to understand these few things which they've already illustrated for you. So the first thing is to understand what is a one-to-one relation. So this can only be a one-to-one relation when the relation is for every input value, there is only one output value. So if we can look, or if we can make a typical example of a straight line. So a straight line is just like this. So if it's on x and y axis, so you can see that this point here has the one output and one input, one output, one input. So we can literally see that this is now our function. So this can be a one-to-one relation. Now we have what we call a many-to-one relation. That's definitely where a relation is many-to-one. If for more than one input value, there is one output value. So for instance, if our input here gives us the for more than one value. So for instance, it's something like this. Maybe our function is like this. Then here at this specific point, or let's just say here, maybe -1, we can see that we have this output value. We also have this output value. So those are the things which we need to look at, that for more than one input value, then we can be able to have one output value. Great. Oh, no, the one I just did now, it was for the last one, which is a relation in one to many, where we are looking at one input value which has more than one output values. That's the one which I was just drawing right now. Okay, great. Now let's look at the questions 1.1. So if it's your first time to tune in at Yebo Tutor Livestream Help, please do yourself a favor and like, subscribe, comment, and share with anyone so that they can be able to have access to this special video which we are having on this special day. So let's get down and let's solve our problems for the investigation. So as I was solving here before the technical issues, question number 1, determine the type of relation in each of the below cases and give a reason. So determine the type of relation in this. So we can see that on 1.1.1 we have this set A, which is our input, and B is our output. So we can see only 1 is the input, but it have these two outputs, 4 and 9. So if that's the case, so this is a one is to many relation. Then what's the reason? So you come here, because you can see that they say that a relation is one to many if one input value there is more than one output value. So you can see that we only have one input value, which is 1, but it has more than one output value, which is 2. So more than 1, which means we are now saying 2, 3, or 4. So we can see that even 2 here, it has this 1, and this 3 has this 16. But because of this one, which has 2 output values, 4 and 9, this makes this a one-to-many relation. Now we are on 1.1.2. So 1.1.2, we are given this in terms of set. So when we plot this, so this is our x and y axis. So this is something which we all know by now, I suppose. So for instance, when we're plotting this, when it's 1 here, then maybe 3 is here, then we plot a point here. We have 2 is to 5, 2, 5 maybe somewhere here. 6 is to 13, 13 somewhere. So at the end, maybe it's something like this straight line. Mine is not really straight because I'm drawing on this laptop. So you can see that we have one input and it also producing one output. One input, one output, one input, and also one output. So that's why we are saying this is a one-to-one relation. According to the definition, when you're now giving the reason, you can say that it is because for every input value, there is only one output value. You can see that one is producing its only one output value, which is 3. Then after that, you are done and you are ready to move forward. Apologize for that. 1.1.3. So now we are seeing on 1.1.3, we are given -2, and this -2 gives our 0. Okay, cool. Then we have -1. -1 is giving -3. Okay, great. We have 0, which is giving -4. Okay. We have 1 giving -3. We have 2 giving negative. So we can see something that this is not a one-to-many relation. This is also not a one-to-one relation, but this is a many-to-one. So as you can see that this input value here and this input value here has the same output value, which is 0. So you can see that at -2 is 0, and also at 2 is also 0. So in those instances, we can say that this is a many-to-one relation. What's the reason behind it? Because they say that also give a reason. So your reason will be like, for more than one input value, there is one output value. So as you can see that we have -2 is to 0, and we also have 2 is to 0. So for more than one input value, but the output is always constant, it's 0. So that's a many-to-one relation. Then after you're done with that, you get your full 3 marks. Any question, please don't hesitate to type your question on the comment section so that we can be able to be together and help each other and work with each other in the process. Now, moving forward, seems like no one is asking any question here, so I think we can move forward to 1.2. Let's go. 1.2. Now, which of the relations which were question 1.1 to 1.1.3 are functions? Ooh, that's nice. So we need to understand what is a function and why. So for instance, now we are on 1.2a. So at A, we say that we have our answer at 1.1.1. Where is it? We say this one-to-many relation. So for one to many relation, they are now asking, is this a function or not? No, definitely. When it's a one-to-many relation, definitely can never be a function. So I think this is something like this. So you can see like this. So this is not a function, for there is one input there, but there are two different outputs. That's our one is to many relation. So in that instance, this is not a function. But now we now really have to write down so that we can show them that we understand what you are talking about. So we can now literally say that it is not a function. Okay, so why? Because for one input value, for one input value, they are more than one output values. So that's why it's not a function. So I just plotted it now. This is the inverse function of a parabola. You can see that you have a value here, one input value, but it has both two values here. We also have a value here, and that's a one-to-many function. So that's what I'm saying it's not a function. So we are now looking and playing around with what is, how do we determine if it's a function or not, looking at our vertical test, but we're going there. Let's not rush there. Let's take step by step. Now on B, we said on our B it is a one-to-one relation. No, definitely that's a function. So that's a one-to-one relation. So that one definitely, we know that that one is a function. Why? For one input value, there is one output value. So which value was that? So we said we're giving a typical example of a straight line where it's like this. So we can see that for one input value, there's one output value. So then definitely that's one is it's a function. Okay, great. Now on C, we said it's a many-to-one relation. So is a many-to-one relation a function? Of course, yes, it is a function. So it is a function. Why is it a function? So we can now say that for more than one input. Okay, for more than one input value, there is one output value. So then definitely that's our function. Then after now we use the vertical line test to determine whether or not a given function or graph is a function. So to determine whether a graph is a function, do the vertical line test. So now if any vertical line intersects the graph of f only once, then f is the function. But if f the vertical line intersects the graph of f more than once, then f is not a function. So just a typical example, here are our graphs which we have. So we have 1.3.8. This is easy, guys. They've already told you everything. They've already highlighted. Let's underline that. So using the vertical line test, so we said that for if any vertical line intersects the function or the graph of f only once, then it's a function. But if the vertical line intersects the graph of f more than once, then f is not a function. Let's change that to red. Red for danger. Apologize for that. Maybe it's COVID-19 or post-COVID. Great. Now, A is A function? Let's do our vertical line test. So this is our vertical line test. Then definitely not a function. Because when we do the vertical line, or we can say because the vertical line intersects the graph of f more than once, so this is not a function according to this statement which we have here. You see, since we do our vertical line test and it was able to intersect more than once, then that's not a function. Now let's look at B. Is B a function or not? You can check. Here's our vertical line test. It's on intersecting once, intersecting once. So if it's intersecting the graph of f once, then that's it. That's a function. Easy peasy. Now let's look at C. Now we are having that straight line. Is that a function? No, definitely it's not, because you can see that when you do a vertical line test, it's gonna have access to the graph or to graph of f more than once. So this is not a function. Now we are on D. Is this one? No, 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 no. Definitely, this is not a function, because this is just a vertical line test as well. Or we can see that it's not intersecting one. So definitely, it's intersecting more than one. So this is not a function. After we perform our vertical line test, let's look at E. But definitely that one is. You can see that there's a vertical line test, vertical line test. So definitely E is a function. It's f, of course, it's a function as well. Reason being, the vertical line intersects the graph of f only once, so that makes it a function. So don't worry about that one. Let's check this one. Also, this one at fg, this is also a function, which is a parabola, because you can check. You can see that using our vertical line test is just intersecting one. So then definitely that one is a function. Now GH. No, 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 no. It's intersecting twice. So the moment it intersects twice, which means it's not a function. Then we are done with question. This was easy because we're just able to understand this small English, that if our vertical line intersects the graph of f only once, then that's a function. But if it intersects more than once, then that's not a function. That's why we are using our vertical line test. Now we are on part 2. We are moving. We are cruising nicely. If you have any questions, stop me, guys. Comment on the chat section so that you can see what other people are saying, okay, so that you can be able to help each other and work through these problems together. Okay, great. Let's proceed then. Seems like no one has a question so far. Now let's proceed to the next question. Part 2. Part 2, part 2, part 2. We're done with part 1. Now we are cruising to part 2. Right. Now on part 2, what is important is to understand, for the first things, was sort of like just simple questions. Guys, and